Okay, so in this video we're going to assemble the leg pieces. All of these leg pieces were on a 3D printer, FDM 3D printer. The STL files are supplied in the orientation I expect you to print them in. So in this case it would be printed like that, or that. You might require a fair amount of support under here, but that should be okay. So the first thing you should do when we start assembling the leg is sort all the pieces by their legs. There's 4 legs. Each of the pieces is labeled with a back for the back, the B for the back, and an F for the front, and an R for the right, and an L for the left. I drew the on here in silver so we could see them on the camera, but it's actually in the piece itself. You'll see it etched in the 3D print itself. Okay, so first thing I'm going to do is sort. Back right, front left, front right, front right, front left. These two, this is the 2 extra pieces. This is for the Arduino holder and the distance sensor holder, which we've seen in other videos. They're not really part of the legs, but I print them out of the same material at the same time as the leg parts. If we can look real closely on this piece, we can see that it has an F and an R as part of the STL file. So you can tell this is the front right piece. This happens to be the front left piece. They're almost exact mirror images of each other, or they are mirror images of each other. They're not copies of each other, so you have to actually pay attention to the letters. Don't just say, oh, those are the same. The left and the right are mirror copies of each other, so you have to keep them apart. And that's true for all of the leg pieces. The left and the right are mirrors of each other, so you have to know which is left and which is right. And so just look for the little labels on each one. So the first thing we're going to do is glue some pieces together. These primary gear pieces, I couldn't really print all as one piece. So there's an extra piece that needs to be glued on to form that. This is true for all 4 gears. So the first thing I'm going to do is sort of make sure I've got a match. You can see how this piece fits in these little guide holes down here, and then the bolt hole that holds through lines up. So I've got all 4 legs and their pieces, so I'm going to glue them on. So I just wanted to make sure they aligned nicely. And I've got all the right pieces lined up before I start gluing. I am going to glue with this glue. This is a glue I tend to prefer for most of these projects. It's a 2-part glue. It's easy to find. It's similar to super glue. It just has a hardener part that makes it a little bit stronger, I feel. For plastics that super glue doesn't work the best on, this always seems to work. I've printed these pieces out of PETG. This works great for PETG, works great for acrylic, works great for PLA, which is mostly what I use, those plastics. Now we let those sit according to the instructions for a minute before we apply the glue. Okay, so we're going to let those dry. I like to let them dry for 24 hours because these other pieces that we put next to it all have to move, and they're going to be really close to the spots we just glued. So if there's any glue leaking out, I don't want it to stick to my moving parts. This should set in a few minutes, but I like it to be nice and dry before I assemble the legs. So we're going to assemble the legs. We'll just start with the back legs. When they're assembling the legs, this is what they're going to look like. Each of the parts go together fairly specifically. But when they go together, they should move really simple, right? They should be smooth, but not loose, so that everything moves nice and easy. The first thing we're going to do is assemble the back left leg and put this part over top. This is a really precise 3D print. Most 3D printers are going to have a tough time getting this to fit over top of there really nicely. So be prepared to file the inside of this until it fits just snug, not too loose and not too tight. Should rotate really easy, but should also not torque at all. Then we take the actual horn and fit that over top. What I've done here, since we're going to take these 2mm bolts and run it through this horn, I've drilled these holes out so that these fit through here really nicely, the holes that I'm going through, right? And so I've done that with a 5/64. If you happen to have a metric, a 2mm should work fine because it's a 2mm bolt. But 5/64 is pretty close to 2mm, so it slides through there really nicely, right? Now this outer washer, which fits over top and actually holds it on, I'm actually gonna self-thread into this washer, right? So those should print so that it's just snug self-threading into this washer piece here. I found that a 1/16 is a good drill bit to drill those out. If your printer doesn't print perfectly, get a 1/16 or 1.5mm, if you can find that bit to drill these out so that they'll catch and self-tap. So I'm going to put that over top. These are 2mm bolts by 12mm long. I'm going to feed them through from the back side. All right. Push it in, and it should slide right through that hole in my horn, right? And then I'm going to take this self-tapping washer, the nice smooth side, which is usually the side facing down on your printer. And I'm going to self-tap into there. So now I have to screw hard enough to actually tap into that plastic. I self-tap with these 2mm pretty often. This 12mm will come out long enough that I could put a nut on it, but then I'd have to use blue Loctite on each nut, and so you can do it either way. You can put blue Loctite on each nut or just self-tap into these plastic washers. So I haven't come through all the way. I'm going to put another one in there and try and line this up. All right, so I've got all 4 screws on there. Again, these would come out enough to put a nut on there if I wanted to, but as it is, that's nice and snug, spins really easy, doesn't get tight. Next, I'm going to put this leg joint on. This screw this is one of the few screws that comes from the back side. I'm going to flip that over. So this self-taps on this piece of plastic as well, but it just means that this piece, again, nice and smooth. So you can see now it pretty much lays flat. So see this indentation in the back? That should face down. This is the foot, this is the hip, and the indentation in the back faces down. So that should come nice and flush. If it's too tight, you can back it off a little bit so that it's nice and smooth. Here we go. So that back leg is nice and smooth and moves nice and easy. All right, so I'm going to set that aside. Each leg has a secondary gear, and then the horn attaches to that secondary gear. In this case, I've also, since I drilled all of the horns out, this just takes a 6 mil M2 screw. So most of the robot, I try to make the robot use as very few size screws as possible. But that's going to come through there. In this case, we will go ahead and put a nut on it. And I recommend putting some blue Loctite on here just to hold that nut. But just for speed, I'm not going to do that in this video. All right, there we go. So that's the secondary gear with its 4 nuts holding it on. So now I've got one leg assembled. I'm going to go ahead and do the another front leg. The other back leg is exactly the same as they're the exact mirror images of each other. So the parts are not interchangeable, but they look exactly the same, just mirror images of each other. So let's do the front left leg. Again, we take the primary gear, put the leg piece over, and you might have to file that in there a lot to get that to fit nice and smooth, right? You don't want to do it too much, too little. You want that to fit nice and smooth. And again, I'm going to take the horn, fit it over top this way, get my M12. All right, so I've got a nice primary gear spinning around my leg just fine. Then I'm going to take that part, should slip in there. Again, this bolt goes in from behind, the only one that goes in from behind. All right, so that bolt should end up flush with the front of that face, and this should spin nice and freely. All right. And then since we're doing the left side, the recession here on for that bolt for the body frame goes down. Right? And the holes line up. And again, this should slide through the front and self-tap in the back. There we go. So the bolts go in from the front, except this top one. I know I've got it assembled right. It goes together nice. It flows nice and smooth. This indentation is on the bottom of this bottom part. I've gone through the front of my bolts, and it self-taps in the back, except this top one, which goes in backwards. So you can see from the front that this is towards the robot, and so this leg angles in underneath the robot. All right. So now we'll go ahead and put the other front leg together. Same thing. All right, so we've assembled all the legs. Got all 4 legs, front and back, with 2 sets of gears, and we're ready to put them on the robot. Now, this is probably the first time we've turned the robot on, so again, double check that you've got all the 5 volts to the right spot and grounds to the right spot, because if you turn it on and you flipped your 5 volts and ground, you're going to have to buy a new little board. You're going to toast one of the boards and be unhappy. So again, this robot takes 18650s. I recommend when you get your 18650s, you also get a little plastic holder like this so you can carry them around safely. And then a nice external recharger for your batteries. I'm going to flip the robot on its bottom and put these batteries in. There you go. And back on his stand and turn it on. All right, so I should hear the light should come on the Arduino, the main power light. I should see the power light on my controller board down there at the center bottom. The motors might whir a little bit. That's okay. That's a good thing. I have already put the Arduino code on this Arduino from my website. I'm assuming you've already got my code on there because that's what's controlling the motors. You can get your infrared controller out, right? And this is our infrared receiver, which will eventually mount in the frame of the robot, the back of the robot. If I just press the up button, the robot's gonna start walking. So this just, you can tell all the motors are whirring. There's no legs on it, but I just know that it's doing something. And I'm gonna press the OK button, the center button, to make him stop walking. And now I'm gonna press the pound button. The pound button is here. That is my motor trim button. You should only have to do that once to trim all your motors to get them in the right spot. I just want to set all my motors at their center position right now so I can attach the legs at the center position. And so that's why I'm doing that. Once I've done that, I can turn the robot back off. Right? That's all I really needed to do at this point. Just get all my motors centered. Now, you can, with no power supplied to these types of motors, you can twist them and turn them, so just try not to do that, okay? So if my front wasn't facing forward, I would now sort of unattach this and reattach it so that the head is facing forward. I see my tail here is not exactly crosswise either. So I'm going to start with this tail and sort of detach that horn. You won't be able to get it exact because there's the teeth on the horn and the teeth on the motor. That's what the whole trimming mode is about later, but we'll do that later. Right now I'm just getting everything as close as I can based on the teeth of the motor. Right? So now I'm going to start attaching legs. I have the screws that I saved out of my, when I took out all my servos, I set the screws, the mounting screws aside. So let's start with this leg here. So this leg is the front left. Now, you'll see that these etch marks, you'll see the etch marks in the frame and all the way through the frame. That's the guide for attaching the legs. You want to attach these legs as close to those guides as you can get. Right? And again, you won't be able to be exact because the teeth on these motors are about 7 degrees. So you're only going to get accurate to within 7 degrees at this point. So for this secondary gear, I see a teeny little mark up here at the top. There's a teeny little mark up here by the number, which tells where this top tooth goes. So I'm going to do that first. And then I take this front left leg, and this gear in here, this 3D printed gear, is going to mesh with that 3D printed gear. And I want the leg to go on as close to this etching as I can get. All right, so if you look at that as straight on as you can look, you'll see that the etching on the body and the leg itself matches pretty close. Again, you can't get exact because the teeth are within 7 degrees, but I'm pretty close enough. We will adjust that later when we go back into trim mode once we turn the robot on. So now I'm going to go ahead and put these mounting screws in this one because I like its position. Now I have to move this leg. Now that I've moved that leg, it's no longer at its center position. So if I need to readjust that, I'm going to have to turn it back on and press the pound key again to get that back. I'll do that just to show you how that works. So I see I've moved this leg physically. So I'm going to turn the robot back on, right? And I'm going to press the pound key on this pad here. And he went back pretty close. He started to go back just when I turned it on, but I'm pressing the pound key just to make sure it goes back to the right spot. And you want to do that because the default on state is a standing state, not a motor trimming state. And they're similar, but not the same. All right. So I'm now going to do the back leg. Again, so there's a little mark down there that you can see etched into, and that basically shows where this bottom tooth should go on this gear. I want to get as close as I can. Again, you can't get that close, but I'm going to get as close as I can. And then I'm going to take the back left leg and again, get it as close as I can to this etching. I'm not going to be able to get exact, but I'm just going to get as close as I can. So I've got two gears. I've got the gear, these two gears meshing, and the gear on that horn, on that. So working both at the same time. Trying to get it as close as I can. The front leg went on pretty close. This back leg's not quite as close. So you can tell that's about as close as I can get it. It's not spot on, again, because I can't because of the teeth in the gears. I have to match those. So I'll adjust that in a minute. All right, now I'm going to do the other side. Same process. Got a little mark up here, which shows where this gear top tooth should be as close as we can get to it. There's the back one. Again, this little etch mark down there, as close to that tooth as I can get it. It's about as close as I can get that one. That's pretty far off. Okay, now that we have all the legs attached and they're approximately close to the sketches on the etching on the plexiglass, we're going to turn the robot on and make what I call trimming modifications. When I first turn the robot on, it's trying to balance itself. It has a self-balancing code we'll talk about later, but I want to get it into trimming mode, so I'm going to press the pound or the hashtag on the remote. I'm going to point it at the little thing here. That puts it in motor trimming mode. And now, at this point, the legs should align with the etchings. And since this is the first time, they probably don't. So I'm going to adjust each of the motors in turn to get the legs to align. So I'm going to start, since the camera happens to be facing this way, with motor number 4. So you can see motor number 4 here. So I pressed pound, and then the number 4. And now I'm going to press the up and down arrows to move the motor slightly. So now I've moved the motor, and so this now should line up. I always find it easier to do this primary one first. Should line up right over top of the etching. If you face it square, if we face it straight on like that, then we should get it right over top. And we can tell we're square on because we can line up. If you can see the etchings on the other side of the plastic, you can line the etching from one side of the plastic to the other. All right? And so we're trying to line this one up with this etching, and it's mirrored on the opposite side. All right, now we're going to do this other motor, which is motor number 3, or number 5. So again, I'm going to do pound, 5, and the up and down arrows. And I don't have to move that one much. So now this leg matches up with the etchings. If I line the etching on both sides up, I can see that leg lines up pretty well. So I'm going to move on to the next leg. Do the front leg. I'm going to start with this one first, which is motor number 7. You can see the 7 there. So I'm going to do pound, 7. And I'm going to adjust that. This one was pretty close. And then I'm going to do pound 6. And that one started out pretty close too. All right, now I'm going to do the ones on this side. Pound 0. There we go. Now number 1. And I think that's pretty close. Let me double check it myself. Yep. All right, and the last one, we'll start with motor 3 and motor 2. All right, I think that looks pretty good. You really do want those to be as accurate as you can get with your eyeball. So now we do that so that the software knows where the position of all these motors is. So now the software knows that this position is that position in real space, right? So now you would think we could make it walk if I took this off of here and stood it up. I pressed OK. OK is back to the normal stand. The first thing I notice is it's way tilted. So I have to do this, and it's tilted because there's an automatic balancing algorithm. The IMU, or the accelerometer, is just mounted slightly tilted. So we got to fix that. So the way we're going to fix that is put it back on here. And we are going to calibrate the IMU. Okay, so just like we trimmed the motors, we need to trim the accelerometer in the robot. Basically so it knows where up and down is. If we mount it slightly off or things like that, we need to calibrate it. So to calibrate it, I put it in its stand so that the stand is nice and square. I've also got it sitting on my table. I need to know that this table is flat, right? So I've got a little level, and I've just put it on my table, and I've done this already, but I know that my table is as flat as I want my robot to be able to walk. So in that stance, I'm going to again press the pound key, which is sort of my trimming mode. And then once in the trimming mode, this time I'm just going to press the star key. And if I press the star key, what it's going to do is the robot will read the accelerometer settings and assume that this is flat and save those offsets to the flash on the Arduino so that it can just load that every time, so you don't have to do this again ever. You do it once, you should be good to go, and you shouldn't have to do it again. All right, so now that I've done that once, it takes a second or two. I can hit OK, which puts me back into standing. OK just means stand. Now if I put him on the table, he'll stand nice and straight, right? So if I put him back like this, should stand nice and straight. Right. So he's going to try and stand straight. If I put him on this piece of plexiglass and I tilt him, he's going to lean forward. If I tilt him to the side, he's going to lean to the side. This is a really simple dynamic balancing algorithm. You can look it up in the code. I can talk about it in the code. He doesn't do this very much while walking. He really only does this while standing, just to sort of show that it can be done. Doing it while walking is a whole lot harder, and so I don't really attempt it in this particular code. It's saved for more advanced exercises. All right? Now, I could press go and have this guy walk, but he's not going to walk that well. The reason is the walking algorithm is assuming there's a head and tail on here to counterbalance the walking. So I want to put the head and the tail on here before I really have him walking. So that's going to be the next exercise. We are going to add the head and tail and the shell parts, and then we'll start walking around with him. All right? Thanks.